Hello together, and welcome to the session Build a Serverless Startup in 30 Minutes. My name is Fabian Hahn, and I'm a solutions architect at AWS. And in this session, we will build a serverless startup, surprise, surprise. And we will begin with a short introduction. So what are we doing to build and why? Then we will jump right into the building part, and then I will give you an overview about the services we have used to build the application, and then we will wrap up the session in a summary. To start with, I heard about startup is really cool, so I thought, okay, I like to have my own startup, so be flexible, be agile, have a lot of fun, and also, of course, to do something great. So I sit down and thought a little bit, okay, what is the brilliant idea the world needs, and I really can make an impact in the world. And after some ideas, I came to the idea, unicorn mugs. So because everyone in the world loves unicorns, and everyone in the world needs a mug, and so I combined the two, and I have the great idea, which I have a potential market above 7 billion people in the world. So pretty cool here. And because the competition in this market is pretty high, and I give all of you my amazing idea right now, so I have to be really fast in the market to keep my competitive advantage. And so I like to build my startup right away, but I don't like to manage any servers or operation systems or networking, because I only one guy and I haven't that much resources to do all of that. And also it doesn't really differentiate me and my product from other competitors. So I like to go serverless, because I don't have to provision or manage servers, as we have heard in the keynote earlier from Werner. And also it scales with usage. So if I start with only 10 to 100 customers, and then I had hit the jackpot with my over potential 7 billion customers in the world, the application will scale with it automatically. And also I don't pay for idle, so I only pay for the execution when a customer interacts with my website, and so I only pay if I really make interaction with my customers. And also I have availability and fault tolerance built in, so I have a high available platform for my customer that they don't experience any downtimes or outages. I also use GraphQL as my API endpoint, so it allows me to build an API which covers a lot of different data sources from one single point of access. So I can also use existing data or query databases and so on very easily. We will see that in the demo more. And also, I can describe what is possible with the objects I define in this endpoint. And furthermore, it is network optimized for the requests and responses. So the API will only send the data which is really needed on the client and not the whole stack, as we have, for example, in REST APIs. And for the architecture, for the front end, we will build a static website with React.js, which we will host on Amazon S3. And of course, I like to reach customers around the world with a really nice customer experience. We will use a CDN, our Amazon CloudFront, in front of it. And then for the user management, we have Cognito, because I have the great idea. I like to make the unicorn mug a little bit more exclusive. So to be able to order one, you have to be in the unicorn club. But everyone can join the unicorn club very easily, so that I have still the big market, but I have some exclusivity of it. And then in the back end, we will use AWS AppSync, which is the GraphQL server fully managed at AWS, where we will interact with Amazon DynamoDB as a database, and for inserts also use AWS Lambda to be able to do more compute-intense workloads if we need so. And then I would say, let's jump right in. And to start with, we are using Cloud9, the web IDE from AWS. And at the beginning, I just install Node version 10, which I need. for my React.js project, and then we create a new React.js project. So my unicorn website, which makes a sample React.js. Okay, we have to. Here's missing the N, so now we use Node version 10, and then we create the website. And in this time, as React.js started creating the template website, we are going in the console and create the S3 bucket where we'll then host the website. So we create a new bucket. We call it unicorn mark. We will enable automatic encryption, because also, as we have heard in the keynote, you should always enable encryption where possible to secure your data. And then we create the bucket. And we will also create our CloudFront distribution, so the CDN with the 166 points of presence around the world, that all the customers, nevertheless, where they are on the globe, can easily access the website. So we go into CloudFront, use a web distribution, and as origin, we use our S3 bucket we have just created, and make a restrict bucket access. That means that only CloudFront can access the S3 bucket, so that every request to the website goes through CloudFront. If you, for example, introduce also a web application firewall or so, that it always go through that. And we use the existing identity. I already created that before, and we will update the bucket policy so that the bucket will be updated to allow the access from the CloudFront distribution. And then we will redirect HTTPS to HTTPS, so that the website always have a secure connection. The rest we can stay at default. And as a default root object, we like to have the index HTML. And then we will create a distribution, and in the background, AWS will then create a CDN for you. That needs a couple of minutes. So in this time, we will go further. The React.js standard website has built so far, and then we can go into it and start it. So with React.js, you have also a very nice development server which runs locally on your laptop or a device, where you can then develop the website pretty easily. And with Cloud9, you have also the possibility to preview the website directly. If we go here on the preview, we see here the website, and Cloud9 is running on a normal EC2 instance. So if you have configured the routing tables in your VPC accordingly, you can also reach it out from the internet. And this is now our standard React.js website we are starting with. And then we close that again, that we have a little bit more space in here. And then I prepared a little HTML template to have a nice looking website to present the product to the customer, which I will copy into my project. So we have some CSS, images, and so on. So I have to first delete this index HTML because we will use a different one. And then we will go in the source folder. So for those who don't know React.js that well, in the source folder we have all the logic more or less, and in the public we have all the static content like CSS files. And then we will copy over the source files here, and then if we go back to the website, we will see that we have now the template. So we have just a single-page website with the mark itself, the introduction, why it's the best mark in the world, and then the different packages you can buy. At the moment, it's just the HTML template, so no functionality here, but we will come to that. So, and then at the next step, as I mentioned, we don't have any functionality yet, and so we like to interact with the AWS resources we have seen in the architecture slide. And for this, for that, we have the AWS Amplify library, which is a library provided by AWS, which makes it really easily to integrate with AWS resources. And so for that, we have to install it. And for that, we will install from npm AWS Amplify. And AWS Amplify has also a specific package for React.js, because React.js have some cool wrappers around, and so we can really make use of the React.js functionality also with Amplify. And as I mentioned before, I like to have some exclusivity of our website, so I like to have a user authentication that only members of the Unicorn Club, after they register for it, can see the website. And for that, we use Cognito, which is our user management tool. And here we will create first a user pool, which is the user pool where the members are registered in. And we go here, and then we have to define the user pool name, which we do unicorn. And then here we have some more options we can put in. The standards are fine here. For the demo purposes, I make the password a little bit more easily, that I can log in pretty quickly. And then we also have to add clients, which get a key to be able to connect to this user pool. So it's an additional layer of security that not everyone can connect to your Cognito user pools that easily. And then we will create an app client here. And now we create the user pool. So now we have a user management system which we can interact with AWS Amplify. But to be able to also interact with AWS resources, we need a so-called identity pool. And it's also from Cognito, which allows you that the customer which is registered with you in the pool goes to AWS SDS, so the secure token service, and get temporary credentials to be able to interact with AWS resources directly. For example, GraphQL in our case, or S3 or other resources, so that you don't have always to use a proxy in any way. Then we have to configure the user pool. So we need the user pool ID, which we have here. And then the app client ID, which we generated here. And then we can create this pool. And here we then see, after a moment, we can now here define the IAM roles for unauthorized and authorized people. For unauthorized is, for example, if you like to have some kind of analytics, web analytics, you can give permission for pinpoint for unauthorized people, so that they also get recognized in the analytics part without are registered with Cognito. And for the registered people, for example, that they are able to access their data in DynamoDB or interact with the APIs. So and then we will just go and allow that. And now we have created the entity pool for that. So now we have our user pool in AWS and our website, and now we like to combine them. And for that we use, as mentioned before, AWS Amplify. And for this we go in the app.js, so that it's our main React.js class where we define our website. At the moment, we see in the render method that we call the shop.js, which we will see in a second, which contains the HTML code. And here we will import Amplify, which we installed, and then config AWS Amplify with a configuration file that it knows which resources to use. And for that, we need to create the config file, which we go in here. Oh, no, that's the index. So here it's the index file. And for that, we configure for Amplify that they find the resources. So we have, for example, which region and then the IDs. So we have to bring the IDs in here. So for example, the app client ID. We configure here, then we need the user pool ID. And configure it here. And then the identity pool ID, which we created beforehand, that I know to which endpoints it has to connect to. So, and after we have configured that, we are going to interact now with the authentication method. So now we see we use the package amplify react because we have now our mother class, which we can use for authentication purposes. And so we say, OK, with authentication, and now I wrap this application JavaScript with this class. And what this does, it do a full authentication method. So if I now call the website, I will prompt to a sign-in UI, which is also brought to you by the Amplify library. You can totally customize it, but I have all the main functions, so log in, sign up, forgot password, and all the stuff. And so I like to create now my account to be able to access the website and buy the unicorn mug. So if I hit create account, it now asks for a confirmation code because the email address will be verified. So I get in some seconds email on my email account. And this is all done by Cognito automatically, so you don't have to configure email server or whatsoever. That's all done automatically. You can also enable that also the mobile phone number will be verified, so you can customize it there right away. And here I got my verification code. And after I confirm that, my user is activated. And if I now log in, I will see the website again. And yeah, so I have a little CSS trouble in the top. So OK, now it works. But so now we have the exclusivity. So you need to log in to see the page. So you're now part of the Unicorn Club. But as next, you would like to have some welcome note in the top corner, maybe also a logout possibility. So if you like to log out from the website, you could do this also with the Amplify app. They would introduce your own menu bar on top, but we will do that by ourselves to see also the lower library functions. So for that, we will go in the shop.js, which has all the HTML code of this page we have seen before. And here we will also import Amplify, but not React stack, so Amplify itself. And here the auth method. And the auth method is more or less the class for Cognito to interact with. So I have here a function like sign in, sign up, or also log out, which we'll use in a second. And then we will configure some functions. So in the constructor, it's more or less the state management in React.js. So we will have a user in our state of the website. And then in the component, we'll mount, as the name states, if the website will be created, we will call this function, which calls auth current user info. So it goes to Cognito and get all the user information that we can display the username, for example. And we also created a logout function, which just calls the our sign-out functionality to log out against Cognito. And then we will integrate this also in the HTML, that we display the logout button. And let's have a look. It's this. the logout button and the username. And now if we go to the website again and refresh it, we will see that we see in the top now a little welcome note with the username we queried from Cognito, and also a logout button where I can hit and I get logged out, and then of course I can log back in. So after we have done this, I have now an authenticated user on my web page, and now I like, of course, that they can buy my Macs, because that's my business after all. So I now have to create my endpoint. So we will use GraphQL. It's called AppSync. So we go again to the AWS console, create AppSync. And AppSync is a fully managed GraphQL server, as I mentioned before. We will build it from the scratch and call it Unicorn, because it's amazing. So, and in GraphQL, you need to define a schema. In this case, we have an order, because we like to order something, and a status return. So you also define what the caller gets back for variables, and then you define the elements and the types. So, for example, ID, string, integer, telephone number, or others. And with the exclamation mark, you define if it's mandatory or it's optional. And then you have so-called queries, which are more or less the get functionality. So if you like to receive some information from the API, so we have here get orders, where I get the whole list of orders for one customer, or get one order if I provide the order ID. And the mutation is more or less the change of a data set. So if I like to insert, delete, or update it, I have mutations. In this case, I have a create order, where I like to have the package string. So it's more or less which option of the MAC, and also the email address. And both are mandatory. And as a return, I get the status return. And then I have to save the schema. And I like to have a security border to the API that not everyone can just call it. So I like to use my Cognito identity pool for that. So I go in settings and have at the moment 4 different authentication types: API key, IAM, Cognito, or OpenID Connect. So if I have an OpenID Connect compatible user management system already. In our case, we use Cognito. So I have to define the region where it is, and then what we do on default. The default, I like if we have a user authenticated, I like to allow the interaction with the endpoint that it's able to create an order. And then I save that. And now we need to integrate that again with our website. But before that, we need a data source, because now we have an endpoint, but it doesn't hit any persistent storage. So we create a resource. So we have also a nice wizard here. So you could also create here your own data type, and we will create a database for you. We will use here our existing one. And the order ID, we will, as a primary key, have the user, and as a sort key, the order ID. And then it also allows you to generate automatically some GraphQL schema based on your type you described, but we already have defined it, so we won't create any additional. And now you see it will create a DynamoDB table in the background for you with this data type and create a data source. So data source in AppSync are more or less the endpoints which you can resolve to. So it can be a DynamoDB table, it can be other data sources, can be other API, and you can all integrate it on one call, for example. That's one of the big advantages of GraphQL. So, and to show you that, we will configure the query. So I see here now more or less my types and the queries. For example, here get orders, and here the resolver. The resolver is more or less what should happen if I hit this field. I can also do it on object base. So if I have in order, for example, also status of the status of the carrier, I could call the API of the carrier only for this specific field. So I can really integrate with a lot of different APIs, and my client have only to do one call to get all the relevant information. And here for our get orders, we will use the OrderDB and call it with a query function where we take our user as the identifier, and the user comes from the identity context, and this is from Cognito. So Cognito, if you register, you get a unique ID for the user, and we will use this as a reference for the user because it's fully managed by Cognito, and I don't have to create any own custom user identifier. And we will return a list of objects because we are here getting orders. And then I save this resolver. And then we like also to create the order, because if we don't create an order, we won't have to get some data from the API. So for this, we will create a Lambda function, as we saw in the architecture. So Lambda is the serverless compute service from AWS. And we will use Node.js here, and I prepared a Lambda role, so Lambda access DynamoDB, so more or less it allows the Lambda function to access the DynamoDB table we created before. And here we do nothing very special. We configure the region and call the DynamoDB with the arguments we get from AppSync to create the order. We could also do this in AppSync directly, but in the next step of my startup, I like to integrate here some fraud detection methods, so you need a little bit more complex compute operations. That's the reason why I use Lambda here as a resolver. And then we save this Lambda function. And then we have, again, to create the resolver here. So we have here the mutation of the create order. But before, we have to configure the data source. So here, we also make create order Lambda, and then we can have the different sources, as mentioned, DynamoDB, Elasticsearch, Lambda, other relational databases, HTTP endpoints, or some very custom endpoints. And we will use a Lambda function here in Frankfurt and the create order one. And we will create a role that AppSync is allowed to invoke this Lambda function. And then, a second. And then now we can create a resolver with the Lambda function. Again, here we just define that we like to invoke the data source, as we see in the top. And the payload, we have the arguments, which is provided from the caller, like the package name and the email, as we described in the schema. And then at user, we will give the user object, so what comes from Cognito, where we have, for example, the user ID. And then we will also give an order ID, which we will create here. So you have really also some sophisticated options you can use directly in this resolver, which runs on AppSync. So you can really do a lot in AppSync itself and don't have to call Lambda function all the time. And then we save this resolver, and now we have created our backend. And again, we like to integrate it now with our front end. And for this, we will use Amplify again, which is also pretty straightforward. We will go and import now, in addition to the auth method, the API method from Amplify. With this method, we can call either API gateway for REST APIs or AppSync for GraphQL APIs. And for GraphQL, we need also the GraphQL operation, because that makes then the transformation of the call that it's GraphQL compatible. We then also import the mutation, and this is more or less the structure. I don't see it here. Okay. To copy it down here. So we have here the create order, where we define that we have a mutation, and then how it's called and which variables we will use. So it's pretty simple forward. We have the create order. We will give a package and the email. And then we define here that it's where really the advantage of GraphQL what we like to get back from the API. So here it's the code. In the schema, we define that we have a code as callback mandatory or a message, as you can see in the schema. So we have here status return, which we have defined here, and then we have code and also message. So I could go here and say also I like to have the message back or not. So and at the client, I can define which data I like to get from the endpoint. So I can define API endpoint with which data set as a callback, but as a client, I can really define what data I need, and so I don't have to shuffle all the data around if I not need that. And then we will go and have the function which calls more or less the GraphQL endpoint. So we use here the API from Amplify, the GraphQL method with the GraphQL operation, where we use the mutation description we saw, and then we will give the package name and the email address. And then accordingly, if the status code is not 200, we will give a short alert to the user that it knows something goes wrong. Or if it's successful, we just reload the page that he will see that it was successful. And to call these functions, we make a little update on the package field of the website. So what it simply does, 1 second, is that on the buttons you saw, we will have now an on-click event here, which calls the create order function and then hits with Amplify the AppSync endpoint. And if we go now on the website and we go, for example, here on the package, it should call the endpoint. Let's have a short look what happened. So we got the 404, that it's good, so we have a little live debugging. We didn't tell Amplify where the endpoint is, so we need to define the endpoint of AppSync. So we have, of course, also here an endpoint, and in our configuration file, we have here the URL, so which URL Amplify needs to call to do that. So, and if we now hit the button, we had a refresh, and if we go now here in our DynamoDB table, where we have our order DB, we will see that we have an item with the user, the email, the package, and the order ID. So we have now a functional interaction with our backend from our front end. And of course, the user might like to see what you have ordered previously, so a short overview of the orders. So we will also make this. And for this, we go here. So in the top, we will now import the query. It's the same as the mutation, only that we described that we like to have a query. And we will now, on the component will mount function, we will invoke the GraphQL endpoint with the query functionality to get this information. and then display it. And for this, I prepared also some little HTML that we will display the orders in here. So what we do here is more or less, if we get some orders from the endpoint, we will display a table with the orders. And if we go now on the website, we have here our tables where we get information. And for example, if I order a second one, I see it directly in here. So I can really make very dynamic web pages, can also create webhooks and all this functionality. And to show more or less quickly how some query is built, if we go here, we can log in with our user pool. For that, we need the client API. So this is part of the AppSync service to test your API without a front end or something like that. So I can go here and say, okay, like make a query with get orders. And then I say, okay, I like to call get orders, and I like to get user. So that would be the definition if I like to get only the user. And the big advantages of GraphQL is if I now change something in the front end and also like to get, for example, the order ID to make a different call to update it, I just go in the front end and say, okay, now I also like to have the order ID and don't have to change anything at the back end. So we have really decoupling of front end to back end with GraphQL. So it's definitely worth a look. And now we have done all of that. So we have our website where we have to log in. We have the user authentication. We can create orders. We see the orders. But now, at the moment, it runs locally on my IDE at AWS. So that means now we have to put it on S3. And for this, we will build a static website. So one of the big advantages of React.js is that all is more or less done with JavaScript and HTML and CSS. So I can create a so-called static website, which creates then a HTML file with a JavaScript file, which I can then deploy on, for example, S3. And I don't need some big compute power with EC2 or containers to be able to deliver my front end. So I can really reduce the cost of that here. And it hasn't built. npm run build. So now it creates the build here. And after it's done, we will upload it to S3. And then it's on S3, and we can hit then the endpoint from the CloudFront distribution, our CDN, to see the website very easily. The build process needs some seconds here to finish. Dum, da, dum. So then, at the meantime, we can go to CloudFront and get our URL for the CloudFront distribution. Oh, come on. Typically, that doesn't take that long, but now we are finished. So we now just sync the build folder, which we let created from React.js. And if we now hit the CloudFront distribution with another window, we will see again we have to sign in, so the full functionality is available, even if we only have a static website. And then we can sign in and see the full page, and can also create new orders and see also the orders we have done so far. So that's more or less a quick demo of how fast you can really build a serverless application. And now I will give you an overview about the services we used. So we had Cognito as our user management system, so it's a managed user directory. You can also sign in with existing identities, so for example with Facebook, Google, or Amazon, so that your user don't have to create a new account. You have also hosted UIs, you have seen one of those, and you can also be able to access AWS resources with the Cognito users, and it's OpenID Connect and OAuth2 based, so they're industry standards. AWS AppSync was the GraphQL service, so we have a managed GraphQL server, which is also serverless, so you only pay per invocation, not for idle. We connected to data sources in our accounts, and we have also data sync, real-time and offline capabilities for AppSync, so I can also interact, for example, with a mobile app, and if it's offline and comes online again, I can sync the data there. I can use GraphQL as a facade for any AWS services I have, and it also have the conflict detection and resolution in the cloud with, for example, the data synchronization. And we have enterprise security features with API keys, IAM, and Cognito users, as we have demonstrated. Lambda, as the serverless compute service, we have all the capabilities which we like from serverless, so no servers to provision or manage. We scale with usage. We never pay for idle, and we have availability and fault tolerance built in. And as our persistent storage, we used Amazon DynamoDB, which is a fully managed NoSQL database, document or key value based. It scales to nearly any workload. So Amazon Retail operates, for example, on DynamoDB with billions of records. It's really fast and consistent. It has a lot of fine-grained access control, so I can really give permissions on a field basis. And it's event-driven programming possible with DynamoDB. And as we see, Amplify library is more or less a library for JavaScript, React.js, AngularJS, as well as for iOS and Android, which really enables you as a front-end developer to interact with all the AWS backend resources pretty easily. So, for example, with authentication, as we saw, also with analytics, with Pinpoint, with APIs, or with storage, if I like, for example, to upload some profile images, or also caching and push notifications with apps. So, and in the summary, to bring this all together, the big advantage is that the building blocks are ready to use. You don't have to configure a lot. You can just grab it and use it. Don't have to bring an operating system to harden it and all the stuff. You can really easily start. With serverless, you have the benefit it scales with your needs. It's high available and fault tolerance built in, so you don't have to care about that to be in multiple availability zones because the service brings that automatically. And you pay only for what you use, really on the invocation base. So if no user interacts with your website, you have no costs at all. So that's pretty good also for startups because resources are mostly tight, so you really have only costs if you interact with your customers. And one of the biggest points I like to make here is really, if you're a startup or a Mittelstand company or even an enterprise, really build your minimal viable product as fast as possible. So if you have a product idea, go and build it, build the first draft of it, and then go to your customers and iterate on it. Really go to your customers because they know what they like, and so you can easily make a demo and develop it further with your customers. So don't be 6 months, 1 year in your office and develop something and then interact with the customer really, maybe a little bit more than half an hour, maybe a day or 3, but then really go out there. It's also helpful if you like to present an idea. So a PowerPoint we can create, really cool, it's fine, but to really see how it works, it's really impressive if you can just show a demo, how it works, how it interacts. And then it's really easy to deploy and to develop. As we see with Amplify, we have a lot of capabilities to really easily interact with all the building blocks we can use there. And with that, we have some related breakouts. So we have serverless best practices for configuration management and cost optimization. It's the next session in room 4. And we have also serverless open location data with here, XYZ. It's at 3 p.m. in room 2. And yesterday we had also a talk about full stack in the era of serverless computing, which also gives a good overview about serverless. So if you have missed that talk, it will become in a couple of days available on YouTube as a video. At that moment, I will really thank you all for being here and listen to me. And I really would appreciate if you could complete the session survey or hit the smileys on your way out to rate the session that I can improve there. And if you have any further questions, I will be at the front of the Startup Central, or you can drop me an email at any time. So thank you very much.